hidden line. Next we have to represent the axis in the front view. This is the axis representation in the top view. In the top view you can see the axis as a point. Now in the front view you have to represent the axis with the dash dot line. So up to here draw the projector. From here onwards draw a dash dot line to represent the axis. So here you will get D dash point. Here you will get O dash and P dash axis. Okay. Now top base we have represented. Next we have to name the bottom base. Here E is there. Automatically you will get the E dash point here. F, this is F dash. G, this is G dash. H, this point is H dash. So this is the top and front view of the cube. Next we have to represent the section plane. Section plane is parallel to VP. When the section plane is parallel to VP, then we can represent the section plane with its horizontal trace. And location of the horizontal trace is at a distance of 12 mm from the axis. So this is the axis. From here at a distance of 12 mm, you move 12 mm distance. Here you mark the section plane. So I am taking the section plane something like this. Draw a parallel line to XY, and after drawing the parallel line you draw small and long lines something like this. At the ends you have to dot this. This is the representation of the section. Here we have to represent this section with horizontal trace HT. After representing the section plane, you have to find out the intersections of the section plane with the help of the intersection points of the section plane with the edges of the cube. Now here AB, top edge is there. So with respect to this AB and this HT, we will get one intersection point, that is 1. So you write the details of that here. On AB I am getting 0.1. Next, now move along HT. That means I am moving from left to right. Now I am moving from left to right. While moving left to right, you write the names of visible points. Visible intersection points I am identifying now. While I am moving from left to right, this is visible. Next, I am moving along HT. Somewhere here I am getting another intersection point. This is with respect to BC. That is again top base. So here you give the name of this intersection point as sum 2. Now all the visible intersection points are over. Now you write the invisible intersection points by moving in the opposite direction. Now change your direction, move in the opposite direction, and write the names for invisible intersection points. Here with respect to F and G, we will get one intersection point. That means this line is indicating two edges. BC is top edge, FG is bottom edge. With respect to bottom edge, we will get another intersection point, that is 3. Next, move from right to left. Here we will get one more intersection point with respect to EF. Already we have one intersection point with respect to AB. Now we will get one more intersection point with respect to E and F. So with respect to EF, the intersection point is 4. Now I will write the details here. On AB I am having 1. On BC I got 2. 1 on FG I am having 3. On EF I am having 4. These are the 4 intersection points. Now we have to project all these 4 intersection points to the front view to obtain the true shape of the section. Now I am projecting. So point 1 is in between AB. That means in between A dash and B dash I will get 1 dash. Now 2. Here top view of the second point is there. Now project this to the front view. Now in between B and C we have second point. So here in between B dash and C dash I will get point to 2 dash. Next, in between F and G I am having third. In between F and G I am having third point. That means F dash and G dash are related to bottom. So at the bottom base I will get the third point 3 dash. Next, EF. On EF I am having fourth. EF is related to bottom base in the front view. That means this is the projector. Somewhere here I will get 4 dash. Now join 1, 2, 3, 4. This is the section. So we have to represent the section with hatching. Hatching means 45-degree uniformly spaced lines. So draw the hatched lines, 45-degree uniformly spaced lines. Then we have represented the front view. Now I will show these 4 points on the model. Okay, the invisible point 4. So now on this section, this is 1, 2, 3, 4. With the help of these 4 points, I will represent the section in the front view. Now observe this. This section is parallel to VP. So automatically when you are seeing like this, you will get the true shape of the section in the front view.